Hello students, in this class of ours we are going to find out yet another method of inserting rational numbers between the given rational numbers, and this method we will call as denominator method. If I write here is denominator method. Denominator method. If I write 2 here and 3 here, and let me say this is a line, these two numbers are representing. And if I want to insert one number between these two rational numbers, see, 2 can be written as 2 upon 1, 3 can be written as 3 upon 1, 3 upon 1. This is a integer upon integer, integer and upon integer, and both the q's, q here and q there, is not 0. So undoubtedly 2 upon 1 and 3 upon 1 are rational numbers. Even if I don't write this as 3 upon 1 and this as 2 upon 1, they are rational numbers. And if I have to find out a rational number in between these two by denominator method, the procedure goes like this. The denominator method tells that if you want to insert one number, ensure that the numbers written at both the ends are changed to a form where for inserting one number, 2 must appear as denominator. In simple words, we can say, if I want to insert one number somewhere in between these two, so 2, for inserting 1, I said for this quantity 2 should appear as denominator. For that quantity also 2 should come as denominator. That is when we want to insert one number. So if I write simply 2 by 2 and 3 by 2, this becomes 1 and that becomes 1.5. We were asked to find out a number between 2 and 3, not between 1 and 1.5. So our task is to ensure that this remains 3 and yet the quantity yet below this number we get 2 as denominator. So I will write 2 into 2, and this is 2 by 2, and also here 2 by 2. So now this becomes 4 by 2 and this becomes 6 by 2. Yet if you see, this is 2 and that is 3. So we have not changed the quantities, and yet at the same time, as was the requirement of our denominator method procedure, the requirement was that below these quantities, for inserting one number between these two given quantities, you need to have 2 as denominator. So we have 2 as denominator here, 2 as denominator here, yet this quantity is 2 and that quantity is still 3. This is, if you cancel out, this is 3, this is 2. So we have maintained the values as same. Value is still 2, value is still 3, yet these two quantities have 2 as denominator. Now we can see in between these two we have a space, and 4 by 2, 5 by 2, 6 by 2. So 5 by 2 will be the quantity, rational number between these two. That was one example. Straight coming on to the next example. Let us say we want to insert 9 numbers, 9 rational numbers between 2 and 3 again. So as the procedure demands, okay, for this quantity must have, for accommodating 9, for getting 9 numbers between these two, this must have 10 as denominator. But again, another requirement is value should not change. So what I will write is, I will write this as 10 by 10 and this 10 by 10. See, this becomes 20 by 10, that becomes 30 by 10, 30 by 10, 20 by 10, 30 by 10. This is still 2, that is still 3. If you cancel out, this will become 2, that will become 3. And in between you can see now, in between you can see that for accommodating 9, see 1, 2, 3, 4, 5, 6, 7, 8 and 9. So every line I will write a number 20 by 10, 21 by 10, 22 by 10, 23 by 10, 24 by 10, 25 by 10, 26 by 10, 27 by 10, 28 by 10, 28 by 10 and 29 by 10, and that is 30 by 10. So what we have done is, by keeping 10 as denominator for both these given numbers, we have created a space in between these two numbers so as to accommodate 9 numbers. Now question should arise here, for accommodating one number, why the requirement of getting 2 as denominator was there? So see, I will write here 2 and 3, and let me tell you, between these 2 and 3, the whatever the length is there, every point on this line corresponds to a number which is between these two, and for every number between these two there is a point on the line. Every number between 2 and 3, for every number between 2 and 3 there is a point on this line, and for every point on this line there is a number between these two. So when we are trying to find out, say, let's one number, see one number, and let me say it clearly that here that number I want should be the mid value of these two. Let us say exactly between these two. So I have put one mark here. This one mark or one dot I could put for putting a number, like here 2, there 2, we have put one dot. So I am putting one mark, and I want to write one number which is value of which should be between these two. Now see, the length between 2 and 3 to accommodate one number has been divided into 2 equal parts. And 2 equal parts I am telling because I said I want to find a number in between, so I have put this mark as per my calculations. It seems to be exactly the halfway. So to find a number in between these two, one number I wanted to accommodate at this particular point. For accommodating one number I have put one mark, or say I have put one dot, so that I can write that number there. And as I have told you, every point corresponds to a number. So this point also will, let me say this is a point. This point will also correspond to a number, and that number has to be between these two. For getting one number, I have divided the length into 2 parts. You can see these 2 parts. And for dividing any length into 2, you have to have denominator as 2. So for dividing the length between the rational number 2 and 3 into 2 parts, we have taken denominator as 2, and we wanted to divide into 2 because we wanted to accommodate one number. Similarly, when we want to accommodate 9 numbers, so we will put 9 marks. By putting 9 marks between 2 and 3, we are dividing that exactly into 10 equal parts. And if you are dividing a length into 10 equal parts, you definitely need to divide by 10. So it is usually said like this, that if you want to insert n numbers between 2 and 3, then you should do like this: n plus 1 multiply 2 by n plus 1, also divide by n plus 1. Also do it here, n plus 1 and n plus 1. So we have seen here, for creating 9 equal spaces, we had to divide the length between 2 and 3 into 10 equal parts. For dividing 10 equal parts, we have to take denominator into 10. For dividing into n equal parts, you have to for inserting n numbers, for inserting n rational numbers between 2 and 3, you have to divide the line into n plus 1 equal parts. For dividing the line into n plus 1 equal parts, you have to have denominator as n plus 1. At the same time, it is also mandatory, the value should not change. This remain as 2, that should remain as 3. So what you do, multiply by n plus 1, divide by n plus 1. Value will not change. At the same time, you will have n plus 1 as denominator, which will ensure that your space between 2 and 3 has been divided into n plus 1 equal parts. And n plus 1 equal part, you can accommodate 9 numbers between 2 and 3. So that was all about denominator method.